Yes. Okay. Thank you, everyone, for joining us today as we start our CGIAR Climate Impact Area webinar series. CGIAR, as I'm expecting majority of our audience to be from the CGIAR, so I don't think we need to introduce the organization in great detail, but very briefly, CGIAR is the world's largest publicly funded research organization that works in the field of agriculture, particularly in the global south, in Asia, Africa, and in Latin America. And increasingly, as with the rest of the world, more and more our work has been focusing on climate change. So within the CG, we have 5 impact areas, and climate being one of them. As a part of this particular impact area, from today we are launching a webinar series where the focus would be on issues that the CGIAR currently does not engage a lot in. Because so there's a lot of work that the CG does in the climate space, a lot of work around mitigation, a lot of work around adaptation, but then there are also new and upcoming topics that we have not traditionally engaged in, but there is a value in engaging in those work as we move forward, particularly as we design our new portfolio around mega programs. So with that kind of thinking in mind, my name is Dr. Aditi Mukherjee, and I'm the director of the CGIAR's Climate Impact Area Platform. And I am extremely pleased to invite you all, welcome you all to the first webinar of this series, where we have 2 absolutely excellent speakers who would be talking about attribution science from a climate science perspective and how it can inform loss and damage, which has been a very important policy discussions in the global climate negotiations in the past couple of years. So I think this audience again may not need a lot of introduction what loss and damage really means, but it's basically when we have loss and damages happens when we have not been able to adapt to the climate impacts, and as a result, there are a grave amount of, how do I say, actually losses and damages happening due to the climate impacts, which could have been avoided either through adaptation or through mitigation. So in some ways, losses and damages are an indication that we are failing in our climate action. So in the last COP, starting from the COP27 in Sharm el-Sheikh, when loss and damage made it to the agenda, and in the COP28 in Dubai, a fund was agreed for loss and damage. So in that context, what can science contribute, particularly climate and attribution science, for increasing our understanding of how to attribute loss and damage to anthropogenic climate change? And more importantly, how can that be linked to all the other legal and policy discussions that are going currently around various fora, including the COP, where a lot of very crucial decisions get made. So today we would run this. This will be a 1-hour webinar. We have 2 very well-known speakers, and I'll introduce them briefly, while we would also paste their CVs, their short bios in the chat for all of you to look them up. So after this brief introduction from me, I would invite Dr. Freddie Otto for a 15 minutes presentation. Then we would have a 3-minute audience engagement via Mentimeter on her talk. This will be followed by, again, a 15-minute presentation from Dr. Joyce Kimutai, followed by a Mentimeter talk. That would be followed by a question and answer session for 15 minutes with a brief wrap up from me. And yes, so just to briefly introduce, and we'll also have the CV, the bio pasted on our chat, is Dr. Freddie Otto. She's a senior lecturer in climate science at the Grantham Institute of Climate Change and Environment. And she's the co-founder of World weather attribution, an international effort to analyze and communicate the possible influence of climate change on extreme weather events. Freddie is a very close colleague, and we have worked together in the IPCC synthesis report, and Freddie was voted as one of top influential people by the Times, I think a couple of years ago. With that, and our next speaker would be Dr. Joyce Kimutai. She's also from the Grantham Institute of Climate Change and Environment. Joyce is also belongs to the Kenya Meteorological Agency, and she was a part of the IPCC AR6, along with being a part of the Kenya delegation during the approval sessions. And Joyce's work, Dr. Kimutai's research work, also focuses on quantifying the role and contribution of anthropogenic climate change and extreme weather events. With that introduction over to you, I will stop sharing. For all the audience, you can introduce yourself in the chat, where you are joining from and your name and your center detail. And if you're not from a CG center, from other, wherever you are joining from, while you please use the Q&A box for putting in your questions. We will try to answer as many questions as possible through live interaction that will happen towards the end of this 1 hour session. With that, I'll stop sharing my screen and over to you, Freddie, for your presentation.
Yeah, thank you very much, Aditi, for the introduction. And so I will do a brief introduction in what actually attribution science is and what we at least attribution to extreme weather events, and highlight some of the challenges that are connected with particularly attributing loss and damage. And then Joyce will talk more about loss and damage in the political context directly. And I hope it will be quiet, but I have to apologize in advance. I have some building works in the house, so if you hear some loud hammering, I'm sorry about that. So to start with, I think it's really important to highlight, and most of the audience here, I'm sure, will be very aware of that, but it's still, when we talk about climate change, it is very often still talked about something that will happen in the future, and we all have to answer the question, can we still reach 1.5 or not, very often. And there's always this this idea around that, at least implicitly, that when we reach 1.5, then suddenly there will be an asteroid falling on our head, or a bomb will go off, and things will become much worse than they are right now. And that's, of course, not how climate change manifests. Climate change manifests very gradually through the changing intensities and likelihoods of extreme weather events and other slow scale changes like glacier loss and sea level rise, and all these combined lead to the changes and losses that we are experiencing. So the era of loss and damage has not just begun, it's been, so there are attribution studies that show that even in the Dust Bowl years in the 1930s in the US, the heat waves that occurred then were hotter because of human-induced climate change. So loss and damage is really not something new. But of course, with increasing emissions, the impacts and the losses have grown dramatically in the last few years. And I will use heat waves to briefly introduce the science behind attribution and identifying which of the changes that we see are because of human-induced climate change and which are not. And these are just a few studies, and you can see the headlines here that we have done over the last year with world weather attribution on extreme heat wave. And you can see some of them have actually wording that the first one, extreme poverty rendering Madagascar highly vulnerable to underreported extreme heat, that would not have occurred without human-induced climate change. And the same is true actually for the heat waves in North America and Europe we looked at last year, and also some of the other extremes that we saw in April in Spain and Portugal. So for heat waves, we actually now see extreme events that would not have been possible to occur without human-induced climate change. And so how do we know this, and what does that mean? So this is you taking the extreme heat in Madagascar as an example. The first thing to do when looking at and conducting an event attribution study is we need to characterize the event. And that is, in every attribution study, the most crucial step, because it will determine the results. And of course, it determines what our then assessment of losses and damages. So with world weather attribution, we always try to find an event definition that is most closely linked to the impacts, so to the losses and damages that actually occur. And so in this case, for the extreme heat wave in Madagascar, we explore different ways of characterizing the event, but the main definition that we used was actually the whole of October, because that has led to as far as we can tell, quite a lot of impacts on agriculture, particularly in the area. And once we have characterized the event, so decided, okay, we use actually in this case just the average October temperatures, the next step to do in an attribution study is to find out, in the world we live in today, so in a world with 1.2 degree of global warming that we already have, that was too quick. No, what kind of event is this that we are dealing with in today's world? So in other words, we need to find out what is possible weather in the world we live in today. And to do that, we can use observations and statistical models, but also climate models that simulate the world we live in today. And in this case, we have found that in the world we live in today, we would expect with a 1% chance in any given year to such a hot October to occur. So in other words, it's about a 1 in 100 year event. And you can see that when you look at the left-hand part of my slides in this middle panel, you see this one pink dot and all the empty dots that shows, okay, this is how often we would expect in today's world such an event to occur. And because we know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution, and we know how much warmer it has become globally because of that, we can ask the same question for the world that might have been without human-induced climate change. So we can say, what would be possible weather in the world that might have been without climate change? What would have been possible October temperatures in the world without climate change? And in this case, we find that actually without climate change, we will never get temperatures that are that hot as the observed ones in 2023 in October over the whole of Madagascar. So you can see, and this is what you can see in the left-hand slide in this empty, just in the visualization. But when we look at the actual data, which you can see in the middle, so we have in red the observed, in the observed world of today with 1.2 degree warming, the possible weather events where P1 shows the ones that have the event that has actually occurred, and then the blue one is how it would look like in a world that might have been without climate change. And we can use the same technique and the same approach then, of course, to also look into a world that would be with, for example, a 2 degree warming. And this is what you can see here with in the top panel on the left-hand side, on the most right one, which has quite a few pink dots now. If we would have 2 degrees of global warming, or rather, when we have that, we will see such hot Octobers much more frequently. It's expected to occur about once in 5 years. So this is what we mean with this event would have been impossible to occur without human-induced climate change. That doesn't mean it would not have been warm in October, because you can also ask the question, you can frame the question a bit the other way around. You can also say, okay, we have observed the extreme heat in October. It was almost 25 degrees on average for the whole of Madagascar in October. That's a 1 in 100 year event now. How hot would a 1 in 100 year event have been without human-induced climate change? So instead of looking at the change in likelihood, we can look at the change in intensity. And that's what you can see in the bottom of this illustration on the left-hand side, that the same event would have been about 1.5 degrees cooler in a world without human-induced climate change. And so these two ways of looking at an extreme event, the change in likelihood because of climate change or the change in intensity, is what we can say for all event attribution studies that we do. And for heat waves, the change is really dramatic. And so this is one example, but it's very typical, especially last year. We've seen lots and lots of events that were so hot that they would not have occurred without climate change. But for other types of extreme events, the changes are often quite different. So here are a few examples for heavy rainfall, where we often also do find an increase, but it's much smaller compared to this massive change that we see with extreme temperatures. And sometimes we don't find a change. And sometimes, and that's what one thing I would like to highlight right now, is that we can't actually say what the role of climate change is, because we cannot do the first step of the attribution study, and that is characterizing the event. And this is from a study where we have had several hundred, up to 600 people died because of heavy flooding around Lake Kivu earlier last year, in April and May. But because, and you can see this on the slide here, you see the dots are weather stations, which we have for the Rwandan part of the region around Lake Kivu, but there are no weather stations around the Congo side of Lake Kivu. And you can also see different publicly available rainfall products in the grids. And you can see that for the data where we have stations, none of the freely available observed products have even remotely the right amount of rainfall in the right places. So in the right-hand one, on ERA 5, it doesn't rain at all. And in the other two, it does rain, but not much less, and also in the wrong places. And so we just had no data that we could use to actually characterize the event. And so despite there being huge losses of lives and livelihoods, we could actually not say what the role of climate change is. We can, of course, use the freely available products and say, okay, the 1 day precipitation event has changed, but how much that has to do with the actual event that caused losses and damages is something that's often really difficult, which is one of the reasons why having an ex post analysis of an event to determine the role of climate change can never be a fair use of science to determine any payments or any aid in loss and damage. The last type of events I would also like to highlight, and how to show how attribution results for these kind of events look like, are droughts, which of course are extremely important with respect to agriculture. And first of all, the first study I would like to highlight is the first one that's written here as on the right-hand side. But climate change and not El Nino was the main driver of exceptional drought in highly vulnerable Amazon River basin. And the plot in the middle of my slide is what shows these results. And I know that there are a lot of lines in this plot, but we have in the what we look at here is the SPEI, an index to characterize drought that is basically a combination of rainfall and temperature. So to get the effective rainfall that is available, so the water availability for agriculture and ecosystems. And when you just ignore the lines on the plot here and just look at the colors, these are the drought classifications. So and you have for the dark purple one is an extreme drought, and then going down to yellow, which is still a drought, but not quite so severe a drought. And you can see in pink at the very top of this scale, in a very extreme drought, that's the drought that has occurred in the world we live in today. And a bit to the right of that in green, you can see how intense this drought would have been without the El Nino. And you see that El Nino has played a little bit of a role in the rainfall of this event, but it's very small. When you look instead at the green triangle that's much further down and the orange, which is a severe drought, but not an exceptional drought, that's how this drought would have looked like without human-induced climate change. And when you now can look at the contours, the dashed ones are rainfall, and the non-dashed ones are the ones that show the temperature component in this drought. And you can see there is a change in rainfall, also because of human-induced climate change, but the big change is because of the temperature, and so the increased evapotranspiration. But these results, of course, depend again on how you define the drought. If you had defined the drought just by looking at rainfall, the attributable change in likelihood or intensity would be much smaller. But in this case, we were focusing on agricultural and ecosystem drought because particularly the ecosystem impacts were massive. That seemed to us the right definition. But there is no right answer for what's the best definition of an extreme event, or of an extreme event related to loss and damage, because it always crucially depends on what aspects and what impacts you're actually interested in. And just to finish, so I showed just very briefly some results from my team that we've done within the last year, but of course we haven't just started doing this last year, but since about 10 years, there is now an increasing body of literature that allows us to actually know what of the changes in weather extremes that we see are because, at least in part, human-induced climate change. And I just want to highlight that this was one of the main new things or new findings highlighted also in the IPCC. In this hexagon figure that is part of the summary for policymakers in the synthesis report, as well as in this the scientific basis, so the working group 1 report, where here we see for the heat extremes everywhere where we have evidence of changing heat extremes and the attribution, and the same for heavy rainfall. But for heavy rainfall, you actually do see a lot of gray hexagons here. And that's the part of the world where we don't have enough literature to actually make an IPCC-based assessment of the role of climate change in extreme rainfall and flood events. And that, of course, is a hugely important problem that would make it extremely unfair if this would be the only source of evidence used to determine where losses and damages occur and how big they are. And here is just for completeness the same for agricultural drought. So as a very last comment, of course, I've now only talked about the role of climate change in the hazard, but as Aditi said at the beginning, also if we haven't done adaptation, that of course is a hugely important factor determining the size of the losses and damages. And it's usually vulnerability that determines whether an extreme event turns into a disaster at all. And so another important aspect of, and that's also a development that has only really happened over the last couple of years, is that all our studies now also have a systematic assessment of the role of vulnerability and other and factors like exposure in determining the damages. So whether early warning systems, have people actually were able to access them? Did they know what to do with that information? Where did people live? Sanitary facilities, and all these factors, of course, play a huge role in whether a weather system turns into a disaster. And the same weather event can have very different impacts and very different losses and damages depending on these drivers. So one example with which I will finish from last year was Storm Daniel that happened in the Mediterranean, hitting Greece and Libya. And in Greece, There were a few fatalities, but mainly infrastructural damages, whereas in Libya, the same event led to several thousands of deaths because of a dam breaking down that was actually not maintained for the last 20 years because of the ongoing conflict situation. There was no warning, people had no idea. So this dam broke down in the middle of the night, and so basically killed people in their sleep. So that's one of the really dramatic examples of that. Is, of course, climate change is really important, and the hazard plays a big role, but the number and the size of the losses and damages is largely driven by vulnerability. And so I'll finish here and hope we have some interesting Q&A later. Thank you.
Thanks so much, Freddie. Actually, there are a couple of questions you might see in the Q&A box. Two actually from Thomas Vita. How do you choose the extreme weather events that you investigate? Can you choose freely, or is there some influence of the kind of funding you receive for your work? And the second is, because you publish it very soon after the event, do you also eventually publish it in peer-reviewed journals?
Yes, so we are absolutely free in deciding which events to look at, so that's not dependent on funders, but we have created together with the Red Cross a so-called trigger criterias, and so we choose the events we look at depending on the humanitarian impacts. So we only look at events that have big humanitarian impacts. So, for example, we don't look at agricultural droughts in Europe because they usually don't tend to have a big humanitarian impacts, at least not directly. Hopefully we're planning to publish a paper that sets out actually these criteria, but we haven't published it yet, but that's something to come. And yes, we do most of the studies, unless only the ones that are basically a direct repeat of something we've done in the past. We do also submit to peer review, and most studies that we have been peer reviewed. And on our website, you can find usually a link to the rapid study, and then also a link to the peer reviewed study once it's out.
Right. So there seems to be, there are a few more questions, and all of them are coming for Susie Marshall, partly because my colleague Susie had shared her personal link to everybody. And so I can see multiple Susie Marshalls. Please go ahead and rename yourselves. Apologies for the confusion. There is only one Susie and not whatever 50 that they're showing up. That's because people have just joined with the link that she had shared. It was her personal link. With that, I would now ask the real Susie Marshall to share her screen and have the Mentimeter question up. And the remaining of the questions, Freddie, we will take towards the end of this webinar. So yes. So rest of you who are appearing as Susie Marshall, please go ahead and rename yourself if you're able to. I think the technology is not working perfectly today, but we still had a great talk. Thank you so much, Freddie. So the way this works is you can either scan this QR code or go to www.menti.com and use the code 22460265. And you can put in your responses in here. So we'll have around 2 minutes for this. How do you think attribution science could be useful for your own work?
Looks like it's the only option available to people to thumbs up a response.
No. What does it mean? Can't they input their responses?
Yes, that's what I was hoping would be the case.
Sorry, then let's take it down. And I think today our technology is not quite on our side. So now I would invite, and let's try it later, Susie, again. Let's see if people can actually put in their responses in text there instead of just a thumbs up. May I now invite Joyce, Dr. Joyce Kimutai to present her perspective on the importance of attribution science and loss and damage for the actual negotiations that are going on. Over to you. Over to you, Joyce. You can share your screen.
Thank you, Aditi. You can see my screen well, Aditi?
Yes, I can. Can you do it in the slideshow mode, please?
Yes. Okay, I hope that is visible, and yes. So my name is Joyce, and I'm with the Grantham Institute of Climate Change and the Environment, and also with working with the Kenyan government partly. And today I would like to just really follow on what Freddie had presented. So Freddie has given sort of like the physical, like the us and how we attribute, how we understand the role of climate change in that. And for me, I want to talk about like the role of that science in loss and damage. And so mainly in general, but particularly my talk will be focused on that process in the UNFCCC. So it's really indisputable that we are in an era of loss and damage, and we know that the losses and damages, they result from when efforts to sort of avoid or minimize climate impacts through adaptation and mitigation fail. For adaptation, it could be because there are no adaptive options that are possible to avoid the intolerable risk, or it could be that the options exist, but they are not currently available. And so we realize that then as the climate continues to warm, we will continue to experience losses and damages, and it's likely to really impact heavily or disappropriately on communities that are vulnerable, the environmental systems that are vulnerable, that they are less adaptive and less resilient. And so last year at COP28, and before that at COP27 in
Yes. Can you send me Susie's number? Sorry.
Sorry, Aditi. So loss and damage, just with the recognition that there's continued losses and damages that are actually arising across the world and affecting vulnerable communities. There's been a long debate under the UNFCCC to really establish a fund or to look for resources that can actually support communities to reconstruct or rebuild or even relocate, because there's definitely, we've done so much harm to our environment. We've emitted so much greenhouse gases. Our planet has continually warmed, and then we've got to a point whereby all the efforts that we put in place to try to adapt and mitigate to climate change is actually no longer bringing the positive effect that is intended to do. And what has happened then at the end of the day, or with all those efforts, is that we're seeing losses and damages being experienced by communities. And so there've been a debate under the UNFCCC presented by many vulnerable nations, be it small island states in the Southwest Pacific or the Caribbean, and I think Vanuatu, which is one of the small island states in the Southwest Pacific, started to actually presented a case very early on in the process, saying that they would require compensation for damages, especially from sea level rise. And these could come from developed countries who've had the historical responsibility of emitting greenhouse gases and actually warming the planet. And so then that discussion has been ongoing, and it's picked more that discussion or that debate has garnered a lot of support and has intensified over time in the recent past. And there was really a landmark in Sharm el-Sheikh COP27 in 2022, when the Loss and Damage Fund was established. And then there was 1 year in which a committee was selected to actually decide or suggest modalities for operation to operationalize that fund. And last year at COP28, they presented their findings and sort of the suggestions to operationalize the fund. And so now we have this fund, the Loss and Damage Fund, and the pledges were made last year. They are still quite insignificant with sort of the estimated needs that communities require. But I think it's a step in the right direction, because we have this fund now with us, and so now as the scientific community, then we want to see how, and especially from the attribution side of things, is we want to see how can the science, this fast evolving field of attribution science, how can it support sort of the that debate on loss and damage? How can the science provide sort of the evidence that is required to support that debate? Because we know very well that it's important that most of the decisions are actually informed by best available science. And so then as the community, we are sort of exploring and really looking for insights in how the science can support. And just to say that, so from that loss and damage fund that was established and operationalized last year, there is now, because the pledges have been put in place and there is need to sort of allocate those funds. So that is the other step, where there is an allocation system that has been established. And that system will be sort of taking into considerations countries that are particularly vulnerable, and they will look at the scale of impacts of particular climate events. And they will also take into consideration sort of the looking at recovery and reconstruction costs. They would like to understand what are the estimates of recovery and reconstruction costs that communities will require. And then they, because LDCs, the least developed countries, and seeds have been considered relatively more vulnerable than if compared to other developing countries, is that there'll be a minimum allocation flow for these group of nations. And this allocation system as well, which this allocation system will actually use the best available data and information. And that is really where the attribution science, the science that tries to understand the role of climate change in extreme events, the science that tries to give insights about if we continually warm the planet, what are we likely to see in terms of the impacts, right, that are affecting people. So it's really giving that link between emissions of greenhouse gases, which is really the cause of the warming, with all the way to the impacts that our people are experiencing. And if you add from Freddie's presentation today, is like one of the criteria that we use to do to select studies for analysis is really looking at the impacts that have affected that have affected the people. So we are likely to select a study because of sort of the effects that study or that extreme event has had on the people. So be it people or just the natural systems, we are really likely to study that and understand how the warming and the continued warming of the planet really impacting the people. And so then we want to ask ourselves, what is then the role of attribution science in all these? So in loss and damage, in all these, in even just supporting these allocation system that will be put in place, to be able to give funds to communities, to provide resources to communities, to support national budgets of countries that are highly impacted. And we know most of these countries are actually using most of their national budgets to support other priority needs like health, like education, like poverty eradication and all that. So then it will be important to say, what is the kind of the science that we have? What are the sort of insights from the science that we've done for all this time to be able to sort of inform to some extent? We, of course, quite understand that most of these decisions can be very political, but I think there's really a place of science in informing some of the decisions that will be made. So, I mean, the first important, just to start off, the first important role of the science is actually like providing evidence. So we know for sure that the collective work of the field of attribution science has played a critical role in contributing the existence of loss and damage fund, or just the loss and damage debate in general. And it's really through the ability of this science to attribute extreme events, so rapid events, and also slow events like sea level rise or desertification and all that, to human-induced climate change. It has provided compelling evidence for the urgent need to address the impacts of a warming world. So that is what the science has done. So and then now going beyond that, we want to understand how further can the science, so on top of providing this compelling evidence and showing the need to really address the impacts, and really understanding that beyond adaptation, there's more that needs to be done, is also like sort of assessing or ballparking that sort of the financial needs that can be that can be required. And so attribution science can sort of inform the estimates by like cost estimates by sort of like providing data-driven insights into the cost of impacts that are attributable to climate change. And so if, say, for example, we've understood a number of events and we know for sure that it's the warming of the planet that are actually playing a role in intensifying sort of the frequencies and the magnitudes of these events, or sort of increasing the frequencies and magnitudes of these events, then that can sort of inform the design of the fund, in which the associated cost can act as sort of the baseline for estimating the funds that actually can cover all regions, and including those regions that have limited data or there's little assessment that have been done. And I can give an example of that is like a region like Africa, where like heat waves, for example, have been very much underreported and underdocumented. So the sort of the increasing certainty of the role of human influence in such events in other parts of the world can give a rough quantitative understanding of what is required in terms of responding to extreme heat. So it could form so attribution science can help to form a nice baseline or a design that can actually help to sort of give a rough estimate of what could be required for countries, for communities to reconstruct, rehabilitate, to relocate for regions where they would really need to relocate, or even to change, to shift their livelihoods if the livelihoods that they are pursuing now have become unsustainable. And also the other thing is to look at sort of the type of hazards or the damages that needs to be covered. So if with the science understanding and really knowing that these particular events, there is the role of climate change, and they continue to affect and to modify the risks that are associated with particular hazards, then that sort of gives a baseline of understanding and informing how much needs to be done, and particularly how much of resources needs to be put to support responding to such impacts or to such damages, or how much of those resources, how much of those damages have actually occurred, and how much would communities require in terms of the support. And also to explain is that at the moment, attribution science cannot be performed at the same level of quality everywhere across the world. And so then we ask the question, must losses and damages from attributable events only be compensated? And I think just from the presentation that Freddie did now, she showed this particular event, this flooding event that happened in parts of DRC and Rwanda. And one very challenging, one constraint of actually carrying out that attribution study was that the data was not available. And for the graded data sets that are available, none of them was giving a consistent story in terms of what is required in what kind of data can be used. And so that is why we say that it's then in that case, it's really challenging for other parts of the world to do attribution studies compared to other regions. And that could be the same regions with like the models that we use. So you find that some models are not able to replicate sort of the climate processes that are required to really understand or to simulate the extreme event itself, to replicate the event so that we can get a better definition to enable us to actually carry out that study. And even because for attribution, actually, we use climate models to sort of understand the climate before it warmed and the climate now. And if a climate model is not able to do that work well, then it's really very challenging to do an attribution study in such regions. And the other thing what makes attribution not possible to be performed at the same level of quality everywhere is also the expertise. And you find that mostly in the global north, it's really not possible to, I mean, there are no many experts that are already doing these studies, especially on a routine basis. And sort of that hampers or, I mean, the quantity of studies that have been done in, for example, the global south. And so then using attribution study using attribution science or requiring actually vulnerable affected communities to produce an attribution study to be eligible for loss and damage fund or resources is more of an ethical issue than, I mean, it's detrimental to climate justice, if you ask me. Thank you so much.
Thank you. Thank you so much, Joyce. And what information-packed talk from both you and Freddie. We are very grateful on behalf of all my CGIAR colleagues. What I see is that we have a number of questions that are already on here. So may I suggest that I'll try and take some 4 or 5 questions. After that, we will give a try to the Menti meter once again. Hopefully, finger crossed, the technology will work this time. And in the meanwhile, any question that we cannot take in this session, we have another 11 minutes to go. May I request both Freddie and Joyce to answer it, by typing your answer against the Q&A. So first question is data quality to attribution science. While we are already witnessing extreme weather events like floods and droughts consistent with 1.5 to 2 degrees warming scenario, how can we further improve the quality and accessibility of climate change data to strengthen attribution science for loss and damage claims? Who would like to take? Perhaps this has a very much a regional angle. Data is quite good in some parts of the world and not so much in the others. Perhaps Joyce or yeah?
Yes, that's a good question. I think one issue that we faced, I mean, with my experience of looking at extreme events across the world, is access, especially to station data. So the ground truthing, to understand what exactly. So we could use, so there are data that exists, like grid data that exists that we could use, or satellite-based data that we'd use. But then it would really be nice to have ground truthing or observed data to be able to validate those products. So I think if we are, I think an important step, which, or something that I would think for me would be important, is really a data sharing policy that doesn't exist in most, especially meteorological services. So it's really hard to access data to do to perform attribution study, and especially station data. But what I think is quite important as well, just on top of that, is really increasing the network of data stations, because sometimes you find that you might be able to access some of these data, but you find that the distribution or the network of the stations, or even the number of stations in a country, are quite few. And so you find that, especially in the tropics, you find that that information cannot give you sort of a concrete understanding of the system if they are sparsely distributed like that. So for example, when you want to look at events like extreme rainfall, you find that those events could be very localized. So they cover very small region, and it'd be nice to have stations data that are well distributed in that region and dense enough to make a meaningful analysis of or rather to get to understand the event better, and that will enable us to define the event better and to actually do a good attribution analysis. So so just quickly to summarize is to say, I think increasing network of stations is important. And the other thing is, it would be nice if the data sharing policies can be improved to actually enable us to understand, because if you don't share your data, then it means we are not able to understand the system. We are not able to provide information on what is required for us to adapt better. We are not able to get information of, are we really even adapting better, or beyond that, and then we're experiencing losses and damages. So basically, I'm trying to say that it's important to have data. Data is important to understand what is happening in the climate system and what is required.
Right. And also IPCC AR6 Working Group 1 had these really effective maps with the hexagon, where they were showing all the areas which are data scarce. And much of the data scarce areas actually happens to be parts of Africa and parts of Latin America, where investments in more hydromet is I think, is absolutely needed, apart from data sharing protocol amongst countries, I think would be. So that's a good point. I have one more question. This is for, maybe Freddie can take this. We know that conflicts and war erode the adaptive capacity of communities to extreme events. How can you calibrate this factor, an increasing challenge in different hotspots of the world, within the loss and damage assessment framework?
Well, that's a big one. If I had a clear answer for that, I would have published that framework. But so I think the main in sort of the existing frameworks that we have, the main thing to take that into account is to clearly and systematically address vulnerability and exposure, and not just to focus on the hazard, which most Aditi was just mentioning the hexagons that I've shown. So these are studies that primarily look at the hazards independent of vulnerability. But more recently, the studies that, especially with world weather attribution, we have published, but also there's a growing understanding in the whole community that they are pretty useless if there is no assessment of vulnerability and exposure as well. So I think that is the most important step. I think I don't think we will, in the timescales that we have available to address loss and damage, we will be able to quantify the role of conflict, but I also don't think you need necessarily to quantify it in order to take it into account fully. So there was another question that's somewhat related a bit around uncertainty earlier. And of course, there's uncertainty in attribution. But in most cases, that really doesn't prevent us from taking action. It's all uncertainty, especially in climate science, is always used as an excuse against action. But even if we can't quantify precisely what the role of climate change is, in most cases we can say it's there, and we have lots and lots of options that we know we need to take in terms of adaptation, that we can take completely independent of the scientific uncertainty.
Right. Freddie, I have two follow-up questions. One is my colleagues have also said, and that's on top of our head as we organize this particular webinar, is what applications do you see of loss and damage in the field of agriculture? And my second question is, given how, given the sheer amount of greenhouse gas emissions that's continuing, do you think your work is getting easier and easier and more of these extreme events are actually attributable to climate change? Are you seeing that? Or maybe in 10 years' time, we can just say that almost every extreme event that happens would be due to climate change?
I think, well, with heat waves, we are already there. So we only really do heat wave attribution studies now because there is still so much lack of understanding, and it's always a good communications opportunity. But from a scientific point of view, we know the answer before we do the study. So for heat waves, I think we are already there. And but of course, that actually increasingly also becomes the boring part of an attribution study, to know how big the role of climate change is. Where they are still important is what we talked about, and will be important is what other factors played in a role, which aspects of vulnerability and exposure played a role. And also, and to answer or try and answer the first question, I think for agriculture, we often struggle to know what are actually, so which crops, what are the sensitivities to particular temperature thresholds. And so to really characterize the weather event that led to the losses is something that we often struggle with. And I think that's a really important area of research, to identify how better which aspects of the weather actually lead to crop failure. Where is it temperature, when in the year, where is it water availability, so that and then if we understand the vulnerabilities better, then also our attribution studies can be more informative.
Thank you, Freddie. So it's just the take-home message for me is exposure and vulnerability is just as important as the hazard part of the story, and that's particularly true when this particular framework is being used to inform loss and damage, because loss and damage, I mean, the same extreme event, in other words, the same hazard does not translate to the same loss and damage, and that how extreme that loss and damage would be really depends on the existing vulnerabilities. So that's, I think, a very clear point that comes from both of your presentations. With just 2 minutes left, I just want to try our Menti meter one more time, fingers crossed. Hopefully we will work. And for the remaining questions, if Freddie and Joyce, you can take some time to answer these. Whatever remains unanswered, we will make sure that we come back to you later. So Susie, can you share the Mentimeter? Okay, is that the previous question? Do you have any more questions? Or is it the previous one that people are answering?
I think people can answer both questions now. So it'll be one and then the other.
Can you walk us through the two questions then quickly?
Sure. So thank you very much to everyone for joining, and apologies for the confusion with the name. This is the real Susie Marshall speaking. If you join the Mentimeter using the QR code on the screen now, or join at menti.com and then use the code 22460265, and we should be able to see your responses coming up live as you answer the question. So thank you.
Okay, that brings us almost to the end. Keep answering these questions. These would remain open for a little more while. And let me take this opportunity to thank both Freddie and Dr. Freddie Otto and Dr. Joyce Kimutai for their excellent talk. I think for those of us who are CG scientists and have joined today, we have a lot of food for thought. We understand the importance of the work that we are doing in the context of climate change, vulnerability to climate change. And in our experience, agriculture, particularly agriculture in the global south, continues to remain one of those most climate and weather exposed sectors where there is a lot of vulnerability in many parts of the world. Indeed, the agriculture continues to remain the parking lot of the poor people. And that's kind of all other kind of structural issues leads to a lot more vulnerability among farmers, among pastoralists, and there is therefore our work in this sphere is quite cut out. We have to do a better job in quantifying as far as possible those vulnerabilities and how those are transforming into loss and damage. So with that, I wanted to say that our next month's webinar would also focus on loss and damage, but more from a negotiation perspective, how those have gone through in the UNFCCC context. We would have a speaker from UNDRR, and we would have a speaker from the civil society speaking about the advocacy from the civil society that actually help put loss and damage on the global negotiation agenda. So with that, and Susie, if you unshare your screen, we just wanted to see both Freddie and Joyce, I can, yeah. So bye to all of you. Any remaining unanswered questions, reach out to me and I'll try and make sure that we have the answers. Thank you so much, Freddie. Thank you so much, Joyce. This was an excellent session. We did have some technical glitches given this was our first webinar, but we will get there soon. And stay tuned for our next webinar, which as far as I remember is going to be on 23rd of April. You will get more information soon about the speakers. Thank you and good day, good evening, good night, good morning, wherever you are. And thank you so much, Freddie and Joyce and everybody helping with this, Susie, Gina, the ILRI team who have been managing the Zoom account and all of you. Thanks so much. Bye. And this will be available. This recording will be available.